All right, this is it's a high question for an 8th grade math student. I would consider this to be almost a borderline ninth grade math student question. It says circle the letter next to each equation if it represents a linear function. Well, what's a linear function? You have to know what that is. So a linear function, that word linear, it comes from the word line. And you can see here, it's when the slope does not change. So, okay, that's linear. And of course, function just means each input has one output. So it's important to keep that definition in mind as we go forward here. So, yeah, linear in linear function. So if I look at that first one, letter A, 2x plus 4y equals 16, what you're looking at here is, all right, can we plug in a number for x that's 0 and make sense of this? So that's what I did over here. So you can see in purple I've plugged in 0. So 2 times 0, let's see. 2 times 0, of course, would be 0. And so we're left with 4 times something equals 16. So that something has to be 4. So y would be 4 in this instance. If I plug in 1, so over here I plugged in 1 for x. 2 times 1 is 2. And then we're adding 4y to that. So let's see. 2 plus 4y equals 16. I would have to take away 2 on both sides to get y by itself. So we'd be left with 4y equals 14. And if we divide by 4 on both sides, we get 14 fourths, which is otherwise known as 7 halves if you simplify that. So we get 7 halves here. And then the last one, what we're trying to see right now is my change in y over change in x constant. So let me do this because 4 looks confusing written as 4. I'm going to write it as 8 halves. That way we can easily see, okay, this is going down by 1/2. So if I'm making a prediction here, I would say this would also go down by 1/2 if it's linear, if the slope doesn't change. So let's see. If I plug in 2 and I did the green here, you can see the green for the 2. So 2 times 2 is 4. And then we would multiply 4 by y and set it equal to 16. So if I subtract 4 on both ends, I'm going to be left with a statement which says 4y is the same as 12, and therefore y is 3. And we also know that 3 is 6 halves. So it seems like the slope doesn't change. The change in y is negative 1/2 each time. It's going down by 1/2. And the change in x doesn't change each time either. It's going up by 1. So I could safely assume that this letter right here, letter A, is linear. So let me highlight that in yellow. That way we know, okay, that's linear. So let's move on. And I'm going to go through this. I know it's a little painstaking here, but one at a time. I'm just going to do 3 more, and then you'll start to notice a pattern here. So absolute value, that's what letter B says. And I've changed the problem from absolute value of 2x to just absolute value of x, because that's what matters here. I've got a siren going off in the background. So y equals the absolute value of x. So if x is negative 1, well, then the absolute value of negative 1 is 1, because negative 1 is 1 away from 0. And if x is 0, again, it's 0 away. And if x is 1, well, 1 is 1 away from 0. If you notice here, the change in y is going down 1, and then it's going up 1. So the change in y, it was negative, and then it was positive. If you look at x, it's positive, and then it's positive again. So that's not a constant slope. The slope is changing here. So this would not be linear. And I actually graphed this using the site Desmos. You can see on Desmos, if you graph this, it's going to actually create a V. You can see when x is negative 1, y is 1. And when x is 1, it's also 1. So that right there would be an example of something that is not a linear function. It's a function, but it's just not linear. So we're going to cross that one off. All right, so next one here is x squared. And again, I'm ignoring the plus 5 because it's the x squared that's important. If I was to plug in 0 for x, I'd get 0 for y, because 0 times 0 is 0. If I plugged in 1 for x, 1 times 1 is 1. 2 times 2 is 4. So your change in y is going up 1, and then it's going up 3. Is it changing at the same rate over here? No, it's changing by 1 and then 1 again. So again, the slope is changing. The change in y over change in x is different. And if you were to graph this, you could see why it wouldn't be linear. You can see at 0, it's 0, and at 1, it's 1. At negative 1, it's positive 1. And even at x equals 2, you can see it's 4, and that's a big jump. So this is not linear. So you can go up here and look at everything that is that has an exponent. So c has an exponent. Let's see. H is a special little case. I'm not going to go over that one. This one right here has an exponent. And this is actually the reverse of exponents, the inverse, square roots, so that won't work. And in this one, this is a special case, but it says x times x, and x times x is, of course, x squared, so you can cross that one off. All right, so we're almost toward the end here. 3 to the x power. If we plug in for x here, we, of course, know any negative exponent makes a fraction, so this would become 1 over 3. 3 to the 0 would be 1. Anything to the 0 is 1. 3 to the 1 is 3. And 3 to the second is 9. Again, these are changing by 6. Here they're changing by 2. Here it's changing by a fractional amount, 2/3. The change in y is different every time, whereas the change in x is the same every time. I'm going up by 1. So the slope doesn't stay the same. Just to show you a graph of what this looks like, why it's not linear, you can see that's not a straight line right there. At 0, you can see it's at 1, and then when we plugged in 1, we got up to 3. We plugged in 2, it shot all the way up to 9. So I can cross off the one that has the exponent, which would be letter D. And then just one more to show you here. So we're almost there. You might think that the rest of these are linear. They're not quite. This thing, 4 over x, if you were to plug in 0 for the x, that would make it undefined. Therefore, that one would actually break the rule of being a function. A function has to have each input with one output, and there's really no output there. Not only that, but this wouldn't be linear either if you graphed it. So you could cross off e, and similarly I, if you were to divide each side by x here, you get y equals 24 over x. So x can't be on the bottom. So what we're left with is everything that can be linear. So if it isn't crossed out in red, you can safely assume that those are in fact linear.